Good morning, students. Welcome to our online video class of chemistry. Today we are going to start new chapter 2, acids, bases and salts. Acid, bases and salts. You have already learned about some bases of acid, bases and salt in your previous class. Most of the things that we use in our daily life are acids, base and salts. At present, 115 different chemical elements are known to us. And these elements combine to form a large number of compounds. On the basis of their chemical properties, all the compounds can be classified into three groups: acids, bases and salts. In this chapter, we will study about compounds of acid, base and salts. You have already learned about acids are sour in taste. For example, if we cut a lemon with a knife and taste it, the lemon appears to have a sour taste. The sour taste of lemon is due to the presence of acid in it. Another examples are apple, oranges, tamarind. All these are sour in taste. We can say these are acids. Acid also turns blue litmus paper to red. We know that hibiscus, rose, all those act as litmus in nature. Let's do an experiment using hibiscus as litmus. Now I am going to dip this litmus into vinegar. What do you can observe? The blue litmus change into red. That means it is an acid. From this we can say acids turns blue litmus paper to red. And acids produced hydrogen ion in water. For an example, when hydrochloric acid is dissolved in water to form hydrogen ion and chloride ion, HCl gives H plus and Cl minus. Examples for acids: lactic acid, which is present in curd and milk, and oxalic acid. Spinach and tomatoes contain oxalic acid. Citric acid is present in oranges and lemons. Malic acid is present in apple. Tartaric acid is present in mangoes, grapes, etc. And also the acid which present in tamarind is tartaric acid. The acid which present in an ant is formic acid. And the acid which contained in vinegar is acetic acid. The acid which present in gooseberry is ascorbic acid. Orange also contain ascorbic acid. It is also called vitamin C. And some common acids are sulfuric acid. Its formula is H2SO4. Hydrochloric acid HCl. Nitric acid HNO3. Citric acid C6H8O7. And vinegar or ethanoic acid. It is also called acetic acid CH3COH. All acids can be divided into two groups: strong acids and weak acids. The example for strong acids are hydrochloric acid, sulfuric acid and nitric acid. Acetic acid, formic acid, citric acid, tartaric acid and carbonic acids are weak acids. A weak acid is an acid that is only partially ionized in water. For example, acetic acid is a weak acid. In water, it is partially get ionized. That means only few of the acetic acid CH3COH is ionized as CH3CO minus and H plus. And the strong acids are the acids that is completely ionized in water. For example, hydrochloric acid is a strong acid. In water, it gets completely ionized into H plus and Cl minus. And how do you identify whether a substance is base? Base have bitter taste and soapy feel. Sometimes we say alkali for bases. What is the difference between base and alkali? Most of the bases do not dissolve in water, but some bases dissolve in water. Those bases which dissolve in water without any chemical reaction have a special name, that is called alkali. Base which turns red litmus to blue. Examples for base are potassium hydroxide, sodium hydroxide, calcium hydroxide, magnesium hydroxide, ammonium hydroxide, etc. NaOH, that is sodium hydroxide, KOH, potassium hydroxide, NH4OH, ammonium hydroxide. All this contain OH group. From this we can say bases are the substance which when dissolved in water form OH minus ion, hydroxide ion. Some common alkalis or bases are sodium hydroxide, NaOH, potassium hydroxide, KOH, calcium hydroxide, CaOH twice, and ammonium hydroxide, NH4OH, ammonia solution. Bases are also of two types, strong bases and weak bases. Example for strong bases are sodium hydroxide, potassium hydroxide, etc. These bases which completely ionized in water produce large amount of hydroxide ion, and the weak bases are calcium hydroxide, ammonium hydroxide, etc. These bases when dissolved in water produce a small amount of hydroxide ion. By definition, we can say that acids are the substance which produce hydrogen ion when dissolved in water, and bases are the substance which produce hydroxide ion when dissolved in water. To identify whether a substance is acid or base, we use indicators. What are indicators? Indicators are used to determine if a substance is acid or base. An indicator is a dye that changes color when it is put into an acid or a base. And an indicator gives different colors in acid and base. The most common indicator used for testing acid and base is litmus. Litmus can be used in the form of litmus solution or in the form of litmus paper. Litmus can be used in the form of litmus solution or in the form of a paper. There are two types of litmus paper, blue litmus and red litmus. An acid turns blue litmus to red, and a base or alkali turns red litmus to blue. Types of indicators. Indicators showing different colors in acidic and basic medium. On the basis of this, there are two types of indicators, natural indicators and synthetic indicators. Litmus is a natural indicator. Other example is red cabbage. Litmus is natural indicators whose neutral color is purple. It is made into blue litmus and red litmus for the sake of convenience in detecting color change when an acid or base is added to it. Phenolphthalein and methyl orange are synthetic indicators. The neutral color of methyl orange is orange, and the color change which take place in methyl orange are methyl orange indicators gives red color in acid solution, and methyl orange indicators gives yellow color in basic solution. And in the case of phenolphthalein, neutral color of phenolphthalein is colorless. The color change which take place in phenolphthalein indicators are phenolphthalein indicator is colorless in acidic solution and it gives pink color in basic solution. Let us do an example. Some sample solutions are given. HCl, H2SO4. These are acids. Calcium hydroxide. This is a base. CH3COH, acetic acid. Magnesium hydroxide. It is a base. And you have to find out the color change. If we use red litmus, blue litmus, phenolphthalein or methyl orange as indicators. In the case of HCl, H2SO4, if red litmus is used as indicators, then no color change will occur. If the indicator is blue litmus, then you can observe that blue litmus change into red. If the indicator is phenolphthalein, you can observe the color change is colorless because phenolphthalein indicator is colorless in acid solution. If methyl orange is used as indicator, it gives red color in acid solution. And the neutral color of methyl orange is orange color. And this is added into an acidic solution, it turns red color. In the case of calcium hydroxide, if we use red litmus as indicator, the red litmus change into blue. And if the indicator is blue litmus, no change will occur. And if the indicator is phenolphthalein, pink color can be observed because phenolphthalein indicators give pink color in basic solution. And if the indicator is methyl orange, it gives yellow color. Other examples are acetic acid and magnesium hydroxide. Another indicator is olfactory indicator. Substance whose odor, that means smell, changes in acidic or basic media are called olfactory indicators. The common olfactory indicators are onion, glues, vanilla. How onion is used as indicator? Onion has a characteristic smell. When basic solution like sodium hydroxide solution is added to cloth stripped treated with the onion or onion extract, then the onion smell cannot be detected. If an acid solution like hydrochloric acid is added, we can detect the smell. We cannot destroy the smell of onion. This can be used as test for acid and bases. For example is vanilla extract. It has a pleasant smell. If a basic solution like sodium hydroxide solution is added to vanilla extract, then we cannot detect the smell of vanilla extract. If an acidic solution like hydrochloric acid is added, it does not destroy the smell of vanilla extract. This can also be used as test for acid and bases. Next we are going to study about reaction of acids and bases with the metals. Let us illustrate an experiment for that. For the experiment, take a few pieces of zinc granule in a boiling tube and add about 5 ml of dilute sulfuric acid to it. We will observe the formation of gas bubbles on the surface of zinc granule. Then pass the gas being formed through the soap solution taken in a trough by the means of glass delivery tube. Gas-filled bubbles are formed in the soap solution, which rise into the air. bring a burning candle near a gas-filled soap bubble. The gas present in soap bubble burns with a pop sound, making little explosion. Only hydrogen gas burns, making a pop sound. From this reaction we can say zinc. It is a metal. React with the acid, sulfuric acid, forms zinc sulfate and hydrogen gas. Therefore, from this experiment, we can conclude that acid on reaction with the metal gives salt and hydrogen. That is zinc plus H2SO4 gives zinc sulfide plus hydrogen gas. If it is hydrochloric acid, the reaction becomes zinc plus HCl gives zinc chloride plus H2 gas. Bases also react with metal to form hydrogen. Base plus metal gives salt plus hydrogen. Example is sodium hydroxide on reaction with zinc gives sodium zincate plus hydrogen gas.